If x raised to power 4 minus kx raised to power 3 plus 10x raised to power 2 plus lx minus 3 is divisible by x minus 1. And if when it is divided by x plus 2, the remainder is 27, find the constants k and l. Very interesting question. Now, this is JAMB 1978 Mathematics question 39. So this is a question on polynomial, and we really need two theorems here to help us solve this question. First is the factor theorem, and second is the remainder theorem. So factor theorem can be applied when this one is used, because they said when this polynomial is divisible by this. So if it is divisible by this, it means if you use this polynomial to divide this polynomial, you will have no remainder. So it means that if you set this to be 0 and you equate it to be 0 to get the value of x as 1, if you put 1 inside this equation, this must give you 0. That's the first thing that you need to apply here. So, but for this second one, they said when it is divided by this, the remainder was 27, meaning that if I substitute x equal to -2 by making x equal to 0, setting x equal to 0, x plus 2 equal to 0, then I will have x equal to -2. Let me put it inside this. I must have a remainder of 27. This will help me to achieve two equations that I can solve simultaneously to get the value of k and l. So let's divide the board and solve. First of all, let's use factor theorem to do this. So I have x raised to power 4 minus kx raised to power 3 plus 10x raised to 2 plus lx minus 3. So if I substitute, so if you set this to be 0, x minus 1 equal to 0, that means x equal to 1. Put x equal to 1 inside this, the result has to be 0. So I will have 1 raised to power 4 minus k bracket 1 raised to 3 plus 10 bracket 1 raised to 2 plus L bracket 1 minus 3 equal to 0. Let me simplify this to get an equation. 1 raised to 4 is 1. This will give me minus k. This will give me plus 10. This will give me plus L minus 3 equal to 0. If I rearrange, I will have negative k plus L equal to, if you bring this to the other side, you have negative 1, negative 10 plus 3. So this will be negative k plus 1 plus L equal to this. This will be negative 11 plus 3, that's negative 8. So if you multiply through by negative, you have k minus L equal to 8. Let's call this equation 1. That's the first equation. So now for this second one, we will apply remainders theorem. So if you set x plus 2 to be equal to 0, that means x will be equal to -2. So I can substitute -2 here. It must leave the remainder of 27. So I will have -2 raised to power 4 minus k bracket -2 raised to power 3 plus 10 bracket -2 plus L bracket -2 minus 3 equal to 27. So let us simplify this. This will give me positive 16. So -2 raised to 4 is positive. So, but this is -8, but times k, that will give me plus times -k, that will give me positive 8k. So from here, this will give me -20. Then this is -2l minus 3 equal to 27. Let's simplify. 16 minus 21. Now 16 minus 20, that's -4. -4 minus 3, that is -7. So I'm going to have -7 plus 8k minus 2l equal to 27. So from here, let me come to this side. So from here, let me bring the 7 to the other side. So I'm going to have 8k minus 2l equal to 27 plus 7. If you bring the 7 to the other side, 27 plus 7, that will give you 34. But we can reduce this by dividing through by 2. So this will give me 4k minus L equal to, divided by 2, that will give you 17. Call this equation 2. So from here, you can see if you watch our equation 1 and 2. Equation 1 and 2. Okay, let me rewrite equation 1 here. K minus L equal to 8. Call this equation 1. So if you do equation 2 minus equation 1, I will eliminate L like that. So 4k minus k, that will give me 3k. Minus L minus L, that will be 0. 17 minus this, that will give me 9. So divide both sides by 3. K will be equal to 3. So let's substitute for k inside this. So I will have k minus L equal to 8. So I will have 3 minus L equal to 8. So that means 3 minus 8 equal to L. So L will be equal to what? Minus 5. So that means my answer is 3 and negative 5. Check the options. So 3 and negative 5 are the answers. So looking at the options, we can see that there is no answer in the option. Thank you.